Bismillahirrahmanirrahim. This is the presentation of Mechanics by Group 1. My name is Ikra Kalsoom. Our group members are Adan Tahir, Alishba Nadeem, Ikra Kalsoom, Ariba Bhatt, Amna Shehzad, Hadia Imran and Ariba Akhtar. Our topics are equations of motion, central force field, potential energy and orbits. Our first topic is equations of motion. The equations of motion are the set of mathematical equations that describes the motion of objects under the influence of forces. यानी कि वो मैथमेटिकल इक्वेशंस जो ऐसे ऑब्जेक्ट्स के मोशन को डिस्क्राइब करती है जिनके ऊपर कोई ना कोई फोर्स अप्लाई की जाती है. These equations are derived from Newton's law of motion and are fundamental in physics for analyzing the behavior of objects in motion. There are three main equations of motion, which describes the relationship between displacement, initial velocity, final velocity, acceleration, and time. Next is first equation of motion. V is equals to u plus at. V represents the final velocity of object. U represents the initial velocity of object. A represents the acceleration experienced by the object, and T represents the time elapsed during the motion. Here is the derivation of first equation of motion. We know that according to the definition of acceleration, A is equals to del T del V, where del V is the change in velocity and del T is the change in time. Now we can rewrite this equation as A is equals to T V minus U. Multiplying both sides by T, we get AT is equals to V minus U. Now adding U to both sides, we get V is equals to U plus AT. This is the first equation of motion. If we plot V is equals to U plus AT, it will be a straight line with slope A and y-intercepts U. This means that for every unit increase in time, the velocity increases by a units. This is the graph of first equation of motion. This graph represents how velocity changes with time when an object undergoes uniform acceleration. This is the graph of first equation of motion. Now let's visualize this equation with the help of graph. Consider a graph where x-axis represents time and y-axis represents velocity. If we plot v is equals to u plus at, it will be a straight line with slope a and y-intercepts u. This means that for every unit increase in time, the velocity increases. This graph represents how velocity changes with time when an object undergoes uniform acceleration. Next is second equation of motion. S is equals to ut plus half at square, where S represents the displacement or position of an object, U represents the initial velocity of an object. The derivation of second equation of motion is as follows. Now we will start with the definition of average velocity. We know that average velocity is the ratio of displacement to time, V is equals to S by T. We know that V is also the arithmetic mean of initial velocity U and final velocity V. V is equals to U plus V by 2. Now using first equation of motion, we can express V as V is equals to U plus AT. Now substituting this expression of V into the equation of V average, we get S over T is equals to U plus AT over 2. Now by simplifying, we get S is equals to UT plus half AT square. This is the second equation of motion. Now let's visualize this equation with the help of graph. Consider a graph where x-axis represents time and y-axis represents displacement. If we plot S is equals to ut plus half at square, it will be a parabolic curve. The shape of the curve indicates that the displacement increases with time at an increasing rate due to the quadratic term. This graph illustrates how displacement changes with time when an object undergoes uniform acceleration. Next is third equation of motion. Third equation of motion is v square is equals to u square plus 2as, where v represents the final velocity of an object, u represents the initial velocity of object, a represents the constant acceleration experienced by the object, and s represents the displacement or position of the object. Now the derivation of third equation of motion is as follows. Starting with the first and second equations of motion, we know that v is equals to u plus at and s is equals to ut plus half at square. Now we can solve the first equation for t, which is t is equals to v minus u over a. Now substituting this expression for t into the second equation, we get S is equals to u v minus u over a plus half a v minus u over a whole square. Simplify this expression, we get S is equals to uv plus u square over a plus half v square plus u square plus 2uv over a. Now let's simplify further. By simplifying further, we get S is equals to 2uv minus 2u square plus u square plus v square minus 2uv over 2a. By simplification, we get 2as is equals to u square plus v square. This is the third equation of motion. Now let's visualize the graph of third equation of motion with the help of graph. Consider a graph where x-axis represents displacement and y-axis represents velocity squared. If we plot v square is equals to u square plus 2as, it will be a straight line. The slope of this line is 2a and the y-intercept is u square. Our next topic is central force field. Central force field is a force that is radially pointing and the magnitude is dependent on the distance from the source. यानी कि सेंट्रल फोर्स फील्ड वो फोर्स है जो किसी ऑब्जेक्ट पे रेडियली पॉइंट करती है या उसका जो लाइन ऑफ एक्शन है वो उस ऑब्जेक्ट के सेंटर या किसी भी फिक्स पॉइंट से उस ऑब्जेक्ट पे किसी भी फिक्स पॉइंट से पास करता है और जो उसका मैग्नीट्यूड है वो डिस्टेंस पे डिपेंड करता है. डिस्टेंस सोर्स से लेके जो ऑब्जेक्ट के सेंटर तक का डिस्टेंस है या ऑब्जेक्ट पे किसी फिक्स पॉइंट तक का डिस्टेंस है उस पर उसका मैग्नीट्यूड डिपेंड करता है. जितना डिस्टेंस ज़्यादा होगा उतना मैग्नीट्यूड कम होगा, जितना डिस्टेंस कम होगा उतना मैग्नीट्यूड ज़्यादा होगा. इसकी एग्जांपल्स हैं ग्रेविटेशनल फोर्स, इलेक्ट्रोस्टैटिक फोर्स एंड स्प्रिंग फोर्स. In order for an object to maintain its angular momentum, it should be subjected only to the central force. Similarly, in order for an object to have its motion on the plane, it should be subjected only to the central force. Next, इसकी derivation है the force acting on the object due to the central force field is assumed to be radial. जो force central force field उसके ऊपर apply की जाती है वो radial हम assume करते हैं. Meaning it points along the line connecting to the object to the center. Let r be the radial distance between the objects and the center. By Newton's second law, the force F acting on the object is equal to the mass m times the acceleration a of the object. यानी कि इधर न्यूटन का सेकेंड लॉ हम अप्लाई करते हैं, F is equals to ma. Now since the force is radial, we can write the acceleration a as the second derivative of the radial distance r with respect to time t. तो इसका जो सेकेंड डेरिवेटिव है वो होगा a इज इक्वल्स टू डी आर स्क्वायर ओवर डी स्क्वायर टी. नाउ सब्सटीट्यूटिंग दिस वैल्यू इन द अपर इक्वेशन, f is equals to m dr square over d square t. Given the central force assumption, the force F only depends upon the radial distance r, so we can write f is equals to f into r. Therefore, we can rewrite this equation as f into r is equals to m dr square over d square t. ये जो डेरिवेशन है ये हमें इसे अंडरस्टैंड करने में मदद करती है कि सेंट्रल फोर्स फील्ड किस तरह काम करती है और किस तरह कोई ऑब्जेक्ट जिसके ऊपर सेंट्रल फोर्स फील्ड अप्लाई की जाती है वो किस तरह से मूव करता है, उसकी मोशन क्या होती है. Our next topic is potential energy. The term potential energy was introduced by 19th century Scottish engineer and physicist William Rankine. As we know, an object can store energy due to its position. In the case of a bow or an arrow, when the bow is drawn, it stores some energy which is responsible for the kinetic energy it gains when released. Similarly, in case of spring, when it is displaced from its equilibrium position, it gains some amount of energy which we observe in the form of stress. We can define potential energy as the form of energy that results from the alternation of its position or state. यानी कि पोटेंशियल एनर्जी वो एनर्जी होती है जो किसी भी ऑब्जेक्ट की जो पोजीशन या स्टेट है जब वो उसकी आल्टर होती है तो जो एनर्जी प्रोड्यूस होती है वो पोटेंशियल एनर्जी होती है. नेक्स्ट इज पोटेंशियल एनर्जी फॉर्मूला. The formula for potential energy depends on the force acting on two objects. For the gravitational force, the formula is W is equals to mgh. M is mass in kilogram, g is acceleration due to gravity, h is height in meter. Next is potential energy unit. Gravitational potential energy has same unit as kinetic energy. kilogram meter square per second square. Note: all energy has the same units, kilogram meter square per second square, and is measured using the unit joule. Our next and last topic is orbits. In celestial mechanics, an orbit, also known as orbital revolution, is a curved trajectory of an object. यानी कि एक ऑब्जेक्ट के अराउंड एक कर्व पाथ है, कर्व ट्रेजेक्ट्री है, वो ऑर्बिट कहलाता है. Such as trajectory of a planet around a star, natural satellite around a planet, artificial satellite around an object, or position in space such as planet, moon, asteroid. Normally, orbit refers to regularly repeating trajectory, although it may also refers to a non-repeating trajectory. To a close approximation, planets and satellites follow elliptic orbits. Elliptic orbits are oval-shaped orbits or elongated circles. This is due to the gravitational interactions around Sun, planets, and other outer space objects. Thank you so much. Allah Hafiz.